There is a photograph taken in 1912 during one of the most desperate expeditions ever attempted, captured by a member of Robert Falcon Scott's team as they moved across the Beardmore Glacier deep inside Antarctica. And it is not the image most people remember, not the one at the South Pole marking a race already lost, but a quieter frame showing something scattered across the frozen ground that should not exist in a place like that. Fragments of leaves, impressions of branches, fossilized remains of wood so large that even the men who found them struggled to immediately understand what they were looking at. By that point, Scott and his team were already dying, exhausted, frostbitten, running out of food, fully aware that the journey back would likely kill them. And yet, despite that reality, he made a decision that still does not make sense unless you understand what he believed he had found, because he ordered his men to collect those fossils and carry them, adding roughly 35 pounds of rock to a sled already being pulled by men on the edge of collapse. And when their bodies were finally discovered 8 months later, those specimens were still there, still packed, never abandoned. The question that rarely gets asked is why, because this was not a symbolic act or a moment of curiosity. It was a calculated decision made under conditions where every pound mattered, which means Scott believed those rocks were worth more than the energy required to carry them, more than the risk they added, and possibly more than his own survival. And that only makes sense if what he was holding represented something that contradicted the fundamental assumption about the most hostile continent on Earth. Antarctica was not always ice, and this is not speculation or fringe theory, but one of the most well-established facts in paleobotany, confirmed repeatedly across more than a century of research through fossil evidence collected by dozens of expeditions and analyzed in laboratories and museums across the world, all pointing to the same conclusion that the land now buried under miles of ice once supported not just plant life but entire forest systems, dense, complex, and operating at a scale that challenges modern expectations of what extreme environments can sustain. The dominant species in these fossil records is Glossopteris, a genus of seed fern that spread across the supercontinent of Gondwana roughly 300 million years ago, and its presence in Antarctica is not limited to isolated samples, but appears across multiple regions, particularly in the Transantarctic mountains, where fossilized trunks, root systems, and growth rings provide detailed evidence of trees that grew rapidly, reached significant size, and existed under conditions far warmer than anything the continent experiences today. These were not small or marginal trees struggling to survive at the edge of viability, because the fossil data shows growth patterns consistent with strong seasonal cycles, wide rings indicating sustained development, and trunk dimensions that researchers conservatively estimate at heights between 50 and 60 meters, placing them among the largest tree systems known from the geological record, and more importantly, indicating that they were not anomalies but part of a stable ecosystem that existed over extended periods. What makes this even more difficult to reconcile is the location, because these forests existed at high latitudes, where the environment would have included months of continuous darkness followed by months of constant daylight, meaning these trees were not simply adapted to warmth, but to extremes that no modern forest replicates, suggesting a level of biological specialization that we do not currently see in living systems. Scott understood at least part of this, not in the detailed scientific language we have today, but in the broader implication that the continent beneath his feet had not always been what it appeared to be, and that the fossils he was carrying represented physical proof of a different version of Earth, one where the boundaries of what land could support were far wider than the current distribution of ecosystems suggests. When those specimens reached London in 1913 and were examined at the Natural History Museum, their significance was immediately recognized. Within the scientific community, the presence of Glossopteris confirmed the implications, understood papers written and archived. The findings added to the growing body of evidence that Antarctica had once been covered in forest. Yet outside of that specialized community, the discovery did not spread with the urgency it warranted. Not because it was hidden, but because it was not amplified. At the exact same time this scientific understanding was being established, another system was consolidating power across multiple continents, the modern timber industry, which during the late 19th and early 20th centuries was transforming into one of the most economically significant resource sectors in the world. Building its valuation not on the absolute rarity of wood, but on a controlled perception of scarcity, the idea that large-scale forest resources were limited, slow to regenerate, and therefore inherently valuable in ways that justified concentrated ownership and long-term extraction strategies. That economic framework does not require deception to function, but it does depend on stability, on the assumption that the current distribution of forests represents a natural baseline rather than a temporary condition shaped by climate patterns that have shifted dramatically over geological time. And this is where the Antarctic fossil record becomes more than a scientific curiosity, because it introduces a different possibility, one where the Earth's capacity to produce large-scale biomass is not fixed but variable, not permanently constrained but historically contingent. And that possibility, if fully integrated into how people understand land resources and value, would not simply change how Antarctica is perceived, it would challenge the underlying assumptions that support entire industries, built on the idea of managed scarcity, which is why the most important part of Scott's discovery was not what was found in the ice, but what happened to the meaning of that discovery after it left it. What the Antarctic fossil record reveals is not just that trees once existed there, but that the scale of biological production on Earth in the past was far greater than what the current world suggests, and this is where the implications begin to move beyond geology into something much more difficult to contain. Because these fossils are not isolated fragments, they are part of a consistent global pattern, one that connects directly to the largest carbon deposits on the planet. Since coal itself is nothing more than compressed plant life, and the geological periods that produced these Antarctic forests also generated the coal seams now found across every continent, including Antarctica itself. Those coal deposits have been confirmed through drilling and sampling across multiple expeditions, with layers thick enough to indicate long-term accumulation of organic material, which means the forests that created them were not temporary or marginal, but stable ecosystems operating over extended timescales, producing biomass at levels that exceed anything visible in the modern world. This is where the scale becomes difficult to ignore, because when scientists reconstruct these environments, they are not just identifying species, but estimating growth rates and density. And what they consistently find is that these forests supported large, fast-growing trees in quantities that suggest an Earth far more biologically productive than the one we experience today. And that leads to a critical shift in perspective, because if the planet has already supported that level of biomass, then the current distribution of forests cannot be treated as a fixed limit, but rather as a temporary configuration shaped by present climate conditions, meaning that what we consider natural boundaries may not be permanent at all. In other words, the absence of forests in places like Antarctica does not necessarily represent an inherent incapacity of the land, but a phase in a much longer environmental cycle. And that distinction matters because the way resources are valued today depends heavily on the assumption that current conditions are stable and predictable. The economics of timberland and natural resources are built on managed scarcity, not the idea that wood cannot exist, but that it exists in limited locations and requires long periods to regenerate, which creates value through controlled supply and restricted access. And this framework is embedded in everything from land ownership to industrial planning. If the broader understanding of Earth's historical biomass were different, if it were widely accepted that regions now considered unproductive once supported massive forest systems, then the perceived permanence of resource scarcity would begin to weaken, and that shift would have direct implications for industries that depend on stable expectations of supply and limitation. This does not mean that those industries are based on false information, but it does mean that they rely on a specific framing of reality, one where current environmental conditions are treated as the baseline rather than as one state within a larger range of possibilities, and that framing influences how knowledge is prioritized and communicated. Because the Antarctic fossil record has never been hidden, it has been studied continuously for over a century, with each expedition adding more data, more confirmation, and more detail to the same underlying picture. Yet that picture has remained largely within academic literature rather than entering mainstream economic or cultural discussion in a meaningful way. The pattern is consistent because the research is published, the findings are accessible, and the conclusions are clear, but the translation of those conclusions into questions about land value, resource distribution, and long-term economic assumptions rarely happens, not because it cannot, but because it exists outside the immediate incentives of the systems that shape public understanding. This creates a divide between what is known within scientific communities and what is assumed in broader economic thinking, where one side recognizes that Earth's biological capacity has varied dramatically over time, while the other operates as if current conditions represent a stable and permanent framework. And it is within that divide that the significance of Scott's decision becomes clearer, because the fossils he carried were not just evidence of ancient trees, but evidence that the limits we place on the natural world are often based on incomplete perspectives shaped as much by present conditions as by deeper reality. Which leads to a question that becomes increasingly difficult to ignore, because if the Earth has already demonstrated the ability to sustain far greater biological productivity than we currently see, then the issue is no longer whether those conditions existed, but why that understanding has had so little impact on how we think about resources value and the future potential of the planet. What makes this pattern difficult to recognize is that nothing about it looks like suppression in the way people expect, because the research was never hidden, the fossils were never destroyed, and the data was never denied. And yet the implications of that data never reached the level of public understanding where it could influence how resources are valued or how the natural world is interpreted. This is not because the findings lacked significance, but because of how information moves, because there is a difference between something being known and something being amplified, and the Antarctic fossil record followed a very specific path where it was documented, archived, and technically available, but rarely translated into a form that connected it to economic or strategic questions. When Scott's specimens arrived in London in 1913, and were examined by scientists, their importance was immediately recognized. The presence of Glossopteris confirmed the broader implications understood within the scientific community, papers written and added to the growing body of paleobotanical research. Yet outside of that narrow circle, the discovery did not spread with the urgency it warranted, because the public narrative at the time was focused almost entirely on the human story of the expedition, the tragedy, the endurance, the race to the South Pole. That focus consumed attention, and attention determines which ideas move beyond specialized communities, which means that while the scientific record expanded, the broader interpretation of Antarctica remained unchanged, still seen as a permanent ice desert with no meaningful biological history relevant to modern economic thinking. This pattern repeated itself across the 20th century because each new expedition added more evidence, more fossil sites, more confirmation that Antarctica had once supported extensive forest systems, and each wave of findings was published, discussed within academic circles, and then largely contained within them, never fully integrated into the wider conversation about resources or long-term environmental capacity. The contrast becomes clearer when you compare how different types of geological information were treated during the same period, because findings related to oil exploration, mineral deposits, and energy resources were widely reported, discussed in political and economic contexts, and translated into strategic decisions, while findings that complicated existing resource narratives remained largely confined to technical literature. This difference in treatment was not random, because information that reinforces existing economic structures tends to be amplified, while information that introduces uncertainty into those structures tends to remain specialized, not actively suppressed, but passively contained within systems that do not prioritize its broader dissemination. The result is a kind of informational filtering that does not require coordination or intent, because it emerges naturally from incentive structures where industries, institutions, and media systems all tend to elevate what aligns with current frameworks and overlook what complicates them. And in the case of Antarctic paleobotany, what it complicates is the assumption that the current distribution of biomass on Earth represents a stable baseline, because if the planet has already operated under conditions that produced far greater levels of biological productivity, then the idea of fixed natural limits becomes less certain. This does not invalidate modern resource economics, but it does introduce a level of variability that is difficult to integrate into systems built on predictability, because markets rely on stable expectations, and anything that suggests those expectations might shift over long time scales creates uncertainty that is not easily absorbed into existing models. At the same time, the separation between scientific knowledge and economic interpretation reinforces itself, because researchers focus on data, institutions focus on application, and unless there is a clear incentive to connect the two, that connection often does not happen, leaving certain findings fully documented but functionally isolated from the decisions they could influence. This is why the Antarctic fossil record remained in a kind of suspended state for decades, widely accepted within the scientific community, but largely absent from the frameworks used to think about land resources and long-term value, and that absence is not the result of a single event, but the accumulation of many small decisions about what gets emphasized and what does not. And once you recognize that pattern, the question begins to shift, because it is no longer about whether the evidence exists, but about how different types of knowledge move through society, how some findings become central to decision-making while others remain peripheral, and how that process shapes the way entire industries understand the world. Which brings the story back to Scott, because what he carried out of Antarctica was not just physical evidence, but a question, one that extends far beyond geology, a question about whether the limits we assume are natural are actually stable, or whether they are simply the result of viewing the planet through a narrow window of time. And that question remains open, not because the evidence is missing, but because the conversation that would fully explore its implications has never been allowed to fully develop. The story becomes even more relevant when it moves out of the past and into the present, because Antarctica is not just a scientific subject, it is an active geopolitical space governed by agreements that were designed under very specific assumptions about what the continent is and what it is worth. The Antarctic Treaty, signed in 1959, established the continent as a zone dedicated to peaceful research, effectively freezing territorial disputes and prohibiting military activity, and later agreements, including the Protocol on Environmental Protection, placed strict limits on resource extraction, particularly mining, reinforcing the idea that Antarctica is a place of scientific interest rather than economic potential. On the surface, this framework appears stable, but it contains mechanisms that allow for reconsideration, built-in review structures that acknowledge the possibility that conditions, priorities, or incentives may change over time, and those mechanisms exist because the treaty was never designed for a static world. It was designed for a system that could evolve. In recent decades, the level of activity in Antarctica has increased in ways that are difficult to explain purely through scientific curiosity, with multiple countries expanding research stations, reinforcing logistical infrastructure, and maintaining continuous presence across regions that hold no immediate experimental advantage but significant long-term strategic value. These actions are not random, because maintaining a presence in Antarctica is one of the few ways nations can position themselves within the framework of the treaty, establishing influence without direct claims, building infrastructure that can later support broader operations if the regulatory environment shifts. And that shift does not require speculation about dramatic climate change scenarios or sudden transformations, because even partial changes in accessibility, whether through technological advances, shifting ice patterns, or policy adjustments, could alter the economic relevance of the continent in ways that are currently not part of mainstream discussion. What makes this important in the context of the fossil record is that the evidence collected over the past century does not just describe what Antarctica was, it defines what it is capable of under different conditions, and that capability is not theoretical. It is documented through coal deposits, fossilized forests, and repeated paleobotanical confirmation that the continent once supported large-scale biomass production. If those conditions existed once, then the assumption that the continent is permanently and naturally incapable of supporting similar systems becomes less certain, and that uncertainty has implications that extend beyond science into how future value is perceived, because land that is considered permanently unproductive carries a very different strategic meaning than land that is temporarily inaccessible. This is where the economic dimension becomes impossible to separate from the scientific one, because the value of Antarctica is not determined only by what it is today, but by what it could become under different conditions, and that distinction influences how governments, institutions, and industries position themselves over long time horizons. At the same time, the public understanding of Antarctica has remained largely unchanged, still framed as an isolated frozen environment with limited relevance beyond research, a perception that aligns with the way information about its past has historically been communicated, where the scientific findings are acknowledged but not translated into broader implications. This creates a situation where strategic decisions may be informed by one level of understanding, while public awareness operates at another, not because information is hidden, but because it is not framed in a way that connects the evidence to its potential consequences. And that brings the story back to the beginning, because the fossils Scott carried were not just fragments of ancient trees, they were evidence of a version of Earth that operates under different assumptions than the ones most people use to understand it today, and that evidence has been available for more than a century. The question is not whether Antarctica was once covered in forests, because that is no longer debated within science. The question is what it means that this fact has had so little influence on how the continent is perceived outside of specialized fields, and what that reveals about how knowledge moves, how it is filtered, and how certain implications are allowed to remain unexplored. Because when you follow the pattern from the discovery of those fossils to the present day, what emerges is not a hidden truth, but a missing conversation, one that connects geology to economics, history to strategy, and past conditions to future possibilities, and that conversation has remained largely undeveloped despite the evidence that could support it. Which leads to the final point that is difficult to ignore because the ice covering Antarctica is real, the geological processes that formed it are real, but the idea that the continent has always been what it is now, that its current state defines its full potential, and that nothing beneath that ice challenges how we think about the value of land and resources, is not a scientific conclusion, it is an assumption. And once you recognize that distinction, it becomes much harder to look at Antarctica as just a frozen endpoint, because what lies beneath it is not only a record of the past, but a reminder that the limits we treat as permanent may only be temporary, shaped by conditions that have already changed before and may change again.